So since we do not allow players to change their model within a game, so we need to make them change their model somewhere. So I will let this game to be repeated. So or equivalently let this game to be a repetition of the same stage game. And each stage is the same. So the only difference is that there is a new action B, and B equals to 1 if we add one variable into player i's model, and B equal to 0 if there's no change or we removed some data. So the notation is very bad because the player can add one model and also remove something else. I will consider that B equal to 1 as well, because I introduced a cost to adding that part as well. So the cost is Cn. So we can consider this cost as the cost of building a new economic model, which includes collecting data, raw regression, etc. Just basically to have that model. And of course, this Cn is expressed in terms of discounted utilities. So the model 3.5 is basically a combined version of the previous two. So you have multiple stage and you have multiple players, and it's determined by the fastest. In each stage, player compete, and the fastest player win. And then not necessarily win because he may decide to choose B equal to 0, but then in between the stages, player can prepare and basically fix their models. So the next example I want to have is a stock market example. It's actually the first example that I think of when I start this project. But later on, I think this is too complex to begin with. So I go on to make that consumption good, unique consumption good model. So what I did here is it's basically there at some point here there is a update of one of the variable that changes the fundamental value of a stock, then people start to basically react to this news. So I may need to consider more things, whether this news is good, whether other people think that this news is good, how much will it increase the price, whether other people think that I think that this price will increase, how much it will increase, and so on. There are a lot of things to consider. But the first guy who gets this probably will get the highest profit. So I'm only considering the first guy who reacts to this news. And he must make some computation or have some understanding of what this news, how well it affects the price. For sure, how will it make the price go up or go down? But that is what human will do because for human it takes time to evaluate this news. So that's why people keep reacting. So sometimes it's slow. Sometimes it's because the information is slow. Sometimes it's because the decision is slow. But that's not what I'm interested in. What I'm interested in is the computer players. So what is the computer player? We call them high-frequency players. I mean high-frequency traders. So those traders, basically, they use a computer to monitor the news websites. And once there's a news, that computer analyzes 1,000 different things in 0.01 second and react to that news given that model. So there is a difference. If there is a difference in computational speed, or even if there is a difference in the actual location between the computer and the exchange, then there is a time lag. So people basically need some time. Basically, if I want to compute more, if I want to understand this market more, I can understand it infinitely more complexly because I can estimate basically the higher order beliefs of other investors. And but then that takes time. When I estimate all of them, the state changed already, so my computation is not useful anymore. So that will be the problem. I need to be fast. I need to evaluate a lot, and I have different speed, and I understand that I have different speed. So so then the thing I want to add. So that's just an example. That's not really relevant. But that would just be an example that there is computational speed. And also, the problem I want to illustrate is this problem is not because we are human, so we make decisions very slow. It's even the computers they have time difference in computing. So there requires at least some time to compute a model. That's basically the idea. So the new variable that's introduced here is the gamma here, which represents the time each player used to evaluate one variable in her model. So for example, for humans, it may be the time used to obtain theta n, so basically sample it. But for computers, it's simply the time used to evaluate one component, because that is, even when you are competing with high frequency people, it's important.